Okay, functions, so sinusoidals. Choose the best estimate for 120 degrees in radians. So 120 degrees would be like that big. So what did you tell me before? All the way over here is how much as a number? 3.14. So we're not bigger than 3. And what did you tell me would be a 90-degree angle? 1.57. So the best estimate would be 2.1 probably.
That's what the answer is.
Yeah. They have a 2.8 in here, which is kind of deceiving, but how do you get the exact? 120 degrees times pi over 180. And then you can get an exact if you ever want that. 2.09. Okay. 2, what's the best estimate for the central angle? Look at where the swivel is. Would that have tricked you? Swivel. So this is 3.14, so more than that. You're bigger than 3.14. Does anybody know if you keep going to 270? That'd be, this is like 1.5-ish, 3-ish. What would you think about the top? 4.7-ish. So what do you think? If this is 3.1, 4.7, 4.2 is a guess? Yeah. Okay. Number 3. Determine if it represents exponential, so exponential here. Yes or no? How do you know if it's exponentially growing? If something's 2 today and then it's 4 tomorrow, what should it be the next day?
8.
8. And then what should it be the next day? 16. So what's going on here? What did you do here to here? You times it by 10. Then you times it by 10. Times by 10. Then what? Times by 2. So it's not. It's not consistently having the same multiplier. Okay, what's the y-intercept of this exponential function? What's a normal y-intercept? What's a normal y-intercept of an exponential function? Do you remember what they look like? They normally look like this, right? Because if a graph that's normal has an exponent of 0, what's anything to the 0? 1. But this is different, so what is the y-intercept? Think about the exponent part being 1, but then you're going to have to times it by 5. So your y-intercept would be at 5. Also, right, you can just put it into your graphing calculator, but I hope you can make these connections as well. Is it increasing or decreasing, this function? So the one I drew you is an increasing function. So is it increasing or is it decreasing? That's what it would look like differently. What do you think?
No, decreasing.
It is decreasing because think about a population today. Tomorrow it's 2/3 of what it would be. 2/3, that means it's lowering.
So it was a whole number increasing.
If it has to be compared to 1. If you're lower than 1, like a fraction, right? Like a 0.7 is a decrease. A 1.2 or something like that is an increase. So compare it to 1. Okay, the number of bees in a colony is represented by this. It's exponential function. Da 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 da. Okay, we're going to need to get our calculators out. Type in the equation. Okay, what do you do in your calculator again if you just want a normal screen window? Zoom 6. Yep, that is the trig one. Okay, I don't think it's on there. Ooh, what is our Y-intercept? 120. Ooh, we should make our Y way bigger. So window, what should we do? 500? I don't know. Okay, I got something now. Okay, you can see it's growing. It's increasing. Do you know why it's increasing? 1.15 base. It's increasing. How many bees should the beekeeper expect after a week? So what are our variables here? The number of bees, and D is the number of days. D is the number of days we want to know after a week. So that's 7 days, right? So we're going to use 7. Are we talking an X of 7 or a Y of 7? So if X is 7, what do? Trace mouse, go to the 7. You're going to expect 319 bees. And that I'm going to just round, right? Because it's an answer of the number of bees. I don't really need a fractional part of a bee, a wing or something. Okay. A sine kind of curve. What's the midline? So why don't you tell me what the highest is actually? Why don't we do that? 12 is the high. -4 is the lowest. Can you figure out what would have been in the middle? 4. So when it says the midline, what do you actually need to do when you write it though? Y equals 4 is the midline. Okay, so here, -2, 8, those are the low and the high. What is on the mid? 3, I think, right?
Mm-hmm.
Does that look right? Mm-hmm. So what does an amplitude mean to you?
Point from the midline to the highest or lowest.
How far you're stretching off the midline to the high or the low. So this distance better be the same, right? How much stretch do you have in there? 5. The amplitude is 5. You also know you could have just taken the top and the bottom, which was 10 apart. So therefore you have to be half of that. Okay, determine the period. So the period is a cycle. How long? So let's pretend I'm going to say, let's start here. The next time I get back there is here. How long of a time did that take me? What are you doing every time here? 60? Do you see your scale? Is it up by 60s? 60, 120. What do you got? From 0 to 300 degrees? Right here? Is that the X value? 300? Were you agreeing? So therefore, this length of time took 300 degrees to get through a cycle. So if you hadn't have started at 0, make sure you're figuring out the distance, not just the final number. You got to say from here to here took a span of Okay, can you tell me the range of this function? From low to high is how you would write a range. So from -6 to 4. Or is anybody like the other way? You don't need to do that, but if you liked. Okay, a sinusoidal graph has a maximum at -40, 3, that's the highest. It's at a height of 3. And then it has a midline at -12. So what's the amplitude? If you know the highest and the midline, what are you going to do? You need to figure out the distance.
So it's 15.
15, yep. So from a 3 to a -12, there would be an amplitude of 15. Okay, we have an amplitude of 9 and a midline of -2. So that's what it would kind of look like. I have to go lower 9 and I have to go above 9. So if I drop from -2 and I drop 9 down, what are you at? -11. And -2, if you go up 9, 7. So therefore the range by the way, this should be 18 apart, right? Those numbers are 18 apart. Okay. 13, what is the amplitude of this function? Do you remember when you look at it, what's the amplitude part? The multiplier. That's it, 2/5. So for instance, on 14, if I ask you amplitude, it would have been 10. What is the midline of this? Which part of this equation is the midline? 2. So from 2, you would be going like that, right? The highest you would get is 12. The lowest you would get is -8. That's the idea there? Okay, so the midline is 2, but I should write what in front of it? Y equals. What is the period of this? So what is a normal, if you were always just normal, what's a normal period? What's a normal? Just normal. How long does it take you to go through a whole cycle, a whole circle? 2 pi or 360, however, what language are you talking? That's what kind of idea you have? Okay, so which language do you think this equation is in? Degrees, because I see a plus 60 degree in there. So I'm going to start with 360 and I'm going to divide it by which value?
1.5.
Divide it by b. Period equals, well, I always gave you 2 pi over b. 240 degrees it would take you to get through a cycle. Okay, range. So, what is the midline? What's in the middle? -5. How much should you go up and down? What's the amplitude? 5. So if you add 5, if you subtract 5, what kind of values are you getting to?
0 and -2.
So when I say the range, from -10 to 0. Okay, sinusoidal. So we're going, what do you want to call these? High, mid, and low. So what is 5.5? A high. Then what? Mid, low, mid, high, mid. What should go next?
Oh, yeah.
Mid, low, mid, high, mid, low. Okay, polynomial. So, graphing calculator time. X cubed minus 8x squared minus 3. I'm going to zoom 6 it to see what happens. Okay, I think I'm going to go lower here. I don't know, can't see much low. So Y min. If anybody has anything that works, let me know. Okay, I don't know. I went to -100. Okay, my y's are hundreds. That's what I did. Can see it all. Okay, what is the number of possible x-intercepts? Possible. How many could you have? Up to 3. You could be up to 3. Now what? What's the y-intercept? Without even looking at your calculator, what is it? -3. Because if the x's are zeros, that's what I'm asking you basically, right? The end behavior, so we say it goes from quadrant
3 to 1.
3 to quadrant 1. Domain, this is going left, right, forever, ever.
Mm-hmm.
What about the range? What's the down and up? Also? Okay, so they're both infinite. And how many times could this turn? Up to 2, yep. So you might have to know some characteristics like that. I guess we didn't really need to graph it. You would have known all those things, right? Okay, what is the equation of this? So what do you think it would need for a degree? When it's both opening up, its degree has to be
Wait.
the degree. Is it, what does a first degree look like? A degree 1 is
Oh, yeah.
linear. A degree 2, arrows, let's just talk about the arrows. They go same. A degree of 3, what happens with your arrows? Opposite arrows, right? A degree of 4, same arrows. So we know that we're not we're not odd, so we're an even degree. So what do you think? No, not this degree. This is a cubic degree, so not that one. What do you think? This is degree 1. There's an x with a 1. If you FOILed this, what degree would it be? Squared. And this is cubic. So it's not those. And what do you know about the coefficient?
So yeah.
So it's not those because of the degrees, and it's not this because of negative, so it's that. And if you really wanted to know, if I FOILed, this would make 2 times the 2 makes a 4, which is the Y-intercept, but we had enough info with that. Okay, woo, we get to type in some data. All right, who remembers their buttons? This is the time to maybe think all the things you want to put on your cheat sheet. Stat, edit.
So is it the number of bicycles? Like the top one's going to be L1?
Yeah, L1 is going to go 60, 56. L1, L2, stat, edit. Okay, so we have bicycles, and however many bikes they have is going to determine the floor space they need in their store. Okay, what do we do?
Plot on.
Yeah, I'm going to go y equals. I'm actually going to clear that equation out. I'm going to activate the plot. And then zoom.
9.
This is zoom 9 because it's zoom stat. Okay, there's that. Okay, it tells me linear regression. So I'm trying to make a line, right? You see it? It's in a line. There's just one like way out there. Okay, so stat, calculate, option number 4 is linear regression. Did anybody else get something different?
The first time I did. Oh wait, I got that.
Why?
I got it the other way around.
I'm just looking at the answer key. This is completely a different answer.
Is it different? Oh wait. Different.
Wait, I wonder if they use the, like you said, the variables the other way around.
But I just wrote it backwards by mistake, so.
I bet you my answer key is because they use the variables the other way, but that's okay. We'll still get the answers. Okay, what do the slope and the X-intercept represent in this context? Okay, so we did ours backwards of what they did. So we were saying X was the bikes. So I think I'm going to change this question to the Y-intercept.
So the bikes should have been the L2? Or did that not matter?
Yeah, I'm not sure here. That's okay. We can figure it out either way. Okay. So this is the slope. What does it mean? 1325 per x. What would that mean?
It's increasing the
What is x?
number of bicycles.
Number of bikes. So what do you need? 13.5 per x. Each time you add a bike, you need 13.25 more square foot. So each bike, you're going to have to add another 13.25 square footage. That's what that slope means. Okay, what does the, and so I had to change this because we use different variables. What does the y-intercept mean? So pretend that there was no x. What would that be? If there was no x,
How much square footage there is?
you need just that as a starter, right? You need a store square footage at the start. So you're going to need a store, and then every time you add bike, you're going to think, I got to add this much square footage. Okay, estimate the number of bikes. So I want to know which variable. Estimate the number of bikes. So I want to know x when the store is going to be at 2,500 square feet. Question I need, so this is the y, right? So what is the strategy in our calculator then?
What
y2. I don't even think I have mine in here yet. Okay, so how do we get it in here? We go y equals vars stat equation, enter. Boom, it's in there, graph it. Done. I'm going to go back, y equals, I'm going to deactivate the plot. Got it? And I'm going to go check out my window because what do I want to make sure? It's above 25, okay, and it's good. So graph, oh, I forgot to put in y2 here, 2,500. Okay, second calc, intersect, enter, 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 150. Let's just round it like that. 150 bikes, because it's an estimate, so we'll just say that. Did you get that number? I got 150.55. I guess you could have answered 151 bikes, but okay. Ida hits a golf ball from the top of a hill. So if you think about the situation, you're on the top of a hill. What's going to happen when you hit it? It's going to go how? When you hit a golf ball, what usually should happen, not when I hit, but it goes up and then it should fall down, right? Okay, so let's put that equation in and see if it kind of resembles our idea. So clear. Oh, negative 9.7. I'm going to zoom 6 it, by the way. Okay, we're going to need higher. I can't see mine, so if anybody has a good number yet, let me know. Anybody? 100?
50. And that's kind of,
You had 50?
150.
Oh, 150. Okay. Oh yeah, I have 100 that works, 150 obviously too, but. Okay, there's my height. I went up to 100. Describe the curve of this function. What do you want to say about it? Quadrant what to what? Quadrant
3 to 4.
3 to 4. How many turns? 1 turn. Turns once. What else should we say about it? X-intercepts. How many possible X-intercepts? Okay. Determine the Y-intercept. Actually, I can do it without my calculator. What is it? 11.5. If I don't know, what should I press? Trace. Go to the 0. 11.5. What does it mean? What is it representing?
How high the hill is?
The hill, yep. Because you're right here, which means you're just starting from the top of the hill. What is our thing here? Feet? Meters. The roots of this equation, do you know what roots are? The x-intercepts. The roots are negative 0.2. They've already told us this. You know what? It's not going to hurt you that I make you figure the one out. Do you remember how to do it? How do you figure out what this would have been? Do you remember that function? Second, calculate the 0, and then you move your mouse to contain it. So let's pretend we're finding the right one. Enter, and then go below it. Enter, enter, 5.22. Because you might have to figure that out. Everyone knows that feature? Okay, what do the points represent? It hits the ground there. After 5.2 seconds, it hits the ground, or what are we in? Seconds? Yep. What about this one, though? No, it doesn't exist. Do you actually understand that none of this would have even existed? Because you started. So if I'm actually graphing the real life situation, that's the only part that exists, right? That's it. That's the only part that exists. So this doesn't exist. So that's why they said, what does it represent, if anything? Because it doesn't. I think I had a test question that said, what are the possible restrictions? Well, time can't be negative, right? Okay, match this graph. Okay, what do you know? Well, okay, it's decreasing. So the base has to be less than 1. You know what? They are all that way. What's the y-intercept? 4. So what does that tell me now? It's 3. So this is decreasing, so your base has to be less than 1, which they all are, but you need to make sure it's getting a y-intercept of 3. Okay. From 2012 to 2 to 12, the bird population modeled by this equation. So we have the number of birds for y and time in years. All right, let's graph 250 ln x. I'm going to zoom 6 it again. It looks bad. What do you want to do here? I think more y. Wait, more.
My Y max at 1,000.
1,000?
Yeah.
Ooh.
250 on the X.
Yeah, I want more x. I don't really need any x over here if I don't really want to, but 50 you did it?
Yeah.
And it looks good? So the is it bird population rate?
Yeah.
It's increasing, and then it kind of levels off, but it's still increasing, but just more slowly, right? So is it increasing or decreasing? Well, it's increasing. How would I know just from looking at it if this is a positive value here? So ln curves, remember they reflect if they were to do that. Okay, estimate the bird population in 2010. So is that an X or a Y, the 2010?
X.
It's X, but remember X is the years after 2000. So you're going to tell your mouse to go to 10. So 575.6, so I don't know. We'll go with 576 as an estimate. Explain why it might only apply as a domain from 2002 to 2012. What do you think? I don't know. Maybe the birds only migrated then and then they left, or something in the environment changed. Equations often, when they're like, especially polynomials, they only model the situations for like a small amount of time. Okay, we are gonna have to do a stat edit. We have years and the frogs. Okay, y equals, get everything out, activate your plot. Zoom 9. So it's a log function. That's what they've told us. Logarithmic, kind of like this idea. Just drop it in a basket is good. Okay. Get your equation. So stat, calculate, and then remember it told you linear, or not linear, ln, not linear, because one's lin. Okay. So option number 9, is that what you picked? Okay, I'm getting something like that. Anybody else get a number like that?
Mine's, when I hit that, it's saying
Different.
like I can't hit enter and then it does this.
Go back to your stat edit list. Maybe you did something wrong in there. Just look through that.
Still the same.
Did you do stat calculate number 9?
Mm-hmm. And then it just does
This shows what?
the sentence.
Since mine were 2 and then I did something and I thought it was the same, but it turned out right.
Oh, you had a 1 in front of it on your screen. You didn't have a clear screen.
Oh, was that?
Yeah.
Go on with it.
Okay. Use this to figure out the frog population, how it's going to increase from the 7th to the 10th year. Okay, so I'm going to y equals, that was good?
Yep.
Yeah, that was y. Vars, stat, equation. If you like to graph it just to see how it goes through your dots, that's good. Otherwise, you got to get the dots off of there though. Okay, trace 7. So 225.62. And then you're going to have to trace 10. And you know what? You're probably going to get an error. Does anybody know why I got an error? My window has to fit the 10. So I got to make the window bigger. So if you get an error there, that would be why. Okay, but I asked on how much it's going to increase by. So how much did it go up? So you would subtract here. What is the difference in?
What did you do yesterday? I didn't check on anything today. Oh no! What did you do?
It's an estimate, so you probably could answer. It went up by 8. You could say 7. I think it would have also been okay to use 226. That would have also been fine. So either way, if you would use 226 here, something like that. But you got to show me what you did. Okay. Okay, let's do this one. I'm running out of time here. Let's try to get through one more. Okay, so a gymnast jumps, so let's go y equals clear 11.5 sine. You're probably going to need some brackets here. Pi divided by 2x plus 9.8. Okay, you know what? I need to make sure my mode, my calculator mode. What should it be in? What do you think this language is? Degrees or radians? Radians. So just to make sure, because it's got a pi in there. What if I zoom 7 it? Looks all right, but higher and lower. Zoom 7 does the trig. Okay, so you know what I'm going to think? 9.8 is middle, up 11.5. So I'm going to go just up to a 30 on the y. 9.8 minus 11.5, so I'm going to go to like a negative 5. Something like that. Oh, why doesn't it show it very well? If I do negative 10? Okay, so you can figure stuff out on your calculator, or what is the maximum height? How would you figure that out? Just by not using your calculator. 9.8 is middle, plus 11.5. 21.3 feet. If you didn't know that and you wanted to graph it, then you would, second calc, you don't need to do this, but a maximum. And then you'd have to contain a maximum, right? Left bound, right bound. You know what? I did something wrong when I graphed mine. Why does it look funny? Yeah, mine is graphed wrong. I'd have to figure it out, but I'm running out of time here. Okay, how often does the gymnast jump? So that's talking about the periods. So I'm going to do 2 pi divided by pi over 2. Oh, I know what I did wrong here. I put my bracket in the wrong spot. That's why. I needed a bracket there and then a plus outside. Ta-da! That corrects it. Yep. Okay. So if you didn't know, you could figure out a point and then a point over here and then subtract the times between them. So what happens here? It becomes 4 seconds. Every 4 seconds. So here I start, and then that's a jump, and then here again, so you could figure out the x values between.